So let's say you you go and build your Arduino Uno project, and like look how big this thing is, right? Like takes up so much room, and all you really need is that little microcontroller there. I think the Uno Rev 3s don't have that like dual inline package. So right here, this is a dip package, and it's like quite big. So some sort of like flat package with the little pins coming out. Yeah, no, they all like this thing. Like, look how small that is. You don't need this massive PCB with all this auxiliary stuff just to run your project. So today we're going to be going over everything that goes into that. Like, how do you set this up? What all those auxiliary peripherals are. I mean, if everyone wants, I could go in depth. Is it like, if anyone's in the chat right now, um, is that obvious to everyone watching, or is that something that you'd be interested in learning? Like the crystal oscillator, like over here, you see we have this little crystal oscillator. What is this thing? Like this ICSP, I think that's what it's called. That programming port, how does this like USB to serial converter work? That confused me a lot when I first got into microcontrollers. It's like, what, USB and serial? Like, I think people don't explain 22 picofarads on oscillator. Yeah, I think it's a Pierce oscillator. Um, I'm not sure. They use different architectures, but basically have like an inverter, like a CMOS inverter, and your resonant filter, like your crystal oscillator forms like an RLC filter at a certain frequency, and it just, yeah, resonates. It's an oscillator, and those capacitors, let's search it up. I can't remember, like, honestly I didn't really pay attention in class, but here are those two capacitors. Yes. So Qatar 00, it sounds like you know a lot about this, so this is awesome. I'm glad you can help me with this. If I ever say something wrong, please correct me, because yeah, I mean, we're not all perfect, and I did go to college, so I learned a lot of wrong things. Okay, so let's get started. Yeah, so my goal with this project is I want beginners, so people who don't join this live stream, people who don't want to go super deep and understand everything about it. I just want to create a module that you can drag and drop into your project. Let's say you build up this Arduino like project, whatever it is, and we'll do this for other microcontrollers too. I use ST a lot, but let's say you build your blinking circuit and you want to order a PCB. Getting this onto a PCB is not as straightforward as just like dragging and dropping the IC. So let's like build that module for beginners and anybody to just get right in and start building PCBs. That's really what I kind of want to get out of this. I want more people to be building PCBs. I think that's like a really hard starting point with designing boards, is that there's just so much all at once to learn. I didn't even know what layers and like that you can have vias connecting layers together. I didn't, like, that just flew over my head when I first started. I was like, what the heck is Altium, and like how do you make this work? Yeah, I hope this like really decreases that barrier. Like, just build something and don't understand how it works, but it gets you engaged and you learn like small piece of things here and there. But yeah, so we'll have this page pulled up so we could go back to it later once we get there. We'll get there pretty quick. Arduino Uno R3 R3 module. Like, let's go with absolute minimum, bare bones. I'm gonna go with levels, like level 0. So let's go as bare bones as you can get. Honestly, I'm much more familiar with the STM32 microcontrollers. I've used those professionally in the past, but let's learn about Arduinos. Like, I'm just as new to this as any beginner. Oops, auto complete. No. R3. Yes. Nice. 328p documentation. Schematic. So let's get that pulled up. Yeah, Atmega 328p. Nice. Thanks, Katarp. Let's make sure you could actually get those. I'm gonna go with LCSC because I mean we could go DigiKey or Mauser, but I want to keep this as accessible as possible, and keeping it lower cost is nice. So I did actually look for this a bit earlier, but this is as far as I got back to where I left off. PAU. Yeah, and we have at least LCSC has, where is the stock? Oh yeah, 19,000 of them. That's a healthy amount. I mean, it depends, like on demand. I have no idea what the demand's like, but let's just, why am I doing this? At Mega 328 PAU. Pow. Okay, so here we have our microcontroller. Yeah, here's all of the pricing and availability. We have 117,000 in stock at DigiKey, and we have 20,000 in stock in LCSC, which matches up. Okay, so we know there's stock for this part. We're chilling. Yeah. Now, so this is like, you drag this in, you're like, yay, I'm good to go. There's like 3 main things that we need. Primary. Oh, let me share this for anybody who wants to follow along. I will make it comment only instead of editing, because I've had some issues with that in the past. But yeah, you can open the schematic up right in your web browser, which is nice. So level 0. You need your oscillator. I think we could add decoupling capacitor footprints. Because you can just choose not to populate them if you so desire. I don't think we're gonna add an LDO, like power regulation. So maybe in the next, like level 1 bare bones, if you don't even want to put if you don't have a 3.3 volt rail, you only have a 5 volt or like a 12 volt rail, then yeah, we can slap on an LDO for you, which makes it easier. But I mean, LDOs are pretty simple too. We could keep that as a separate building block. So we have our oscillator, our decoupling caps. Let's throw on oh yeah, some way of communicating. So we'll probably just expose the UART port and programming pins. Let's just go with, what are those things called? Headers? Yeah, programming header, expose UART via connector. What I've always done is I take one of those like FTDI USB to serial converters, and they usually come in like 6-pin. They have like a 6-pin pin out, and then I just have a 2.54 millimeter pitch 6-pin connector on my board. And then you could put like a female header in and stick that programming header in. So in the schematic here, all this is the USB to serial converter. And what they do at Arduino is use another Atmega chip with USB support. And honestly, their schematic is like kind of messy. This is not very readable. Do not take this as an example of how you should make your schematics. Very messy. Yeah. Don't really like it. But, they made this a long time ago. Like, oh, never mind. 2019. Yeah, not really an excuse. Anyways, So we need programming. Yeah, we're gonna the programming like jumpers. Uh, so we could add a button, but that also adds complexity. I'm thinking like with this bare bones, we want to make it as like manufacturable as possible. So the more pin headers we use, I guess the easier it is for somebody at home to manufacture it. Like all you need is a soldering iron. You can just solder it all together, which is pretty fun. Um, Although it would be nice if you can manufacture it. Maybe an LED is good for blink. Yeah, yeah, yeah. Onboard LED. Let me think about that one. It would be good so that you can decode your stuff. Additionally, you can always choose not to populate it. Like, um, let's just say like necessary. Well, we'll make a note. Um, we'll make a note at the bottom that is like, you don't have to populate everything. Only these are mandatory. Honestly, I think the only thing is that oscillator. Even then, I don't think it's mandatory to populate the good to haves. Um, Honestly, with the Atmega 328, I don't think you need to populate anything. Even the oscillator has an internal oscillator. So if you really wanted to, you can go on an 8 megahertz clock, run it like slower, which usually isn't a big deal for like any application Atmega 328 is in. Um, yeah, it's good to have this feature. We could go into more advanced topics too. Qatar 00. I'm not sure how familiar you are like the STM microcontrollers. They can get pretty fancy. Instead of using like this crystal oscillator that is just like a straight crystal, they usually use oven compensated crystal oscillators, or at least it's recommended so that you have a very stable clock source. And another part of that is they have like DLLs and PLLs inside to amplify that frequency. You know, you might have like a 24 megahertz. Yeah. PLL features and stuff. Yeah, you're a pro. You get this. Okay, so for the for anybody else watching, if you're curious, you might have like a 24 megahertz clock, and yeah, those DLLs and PLLs will get you up to like 180 megahertz, 240, whatever it is. Um, I had a project that got me up to 5.4 gigahertz off a 24 megahertz clock, but that was only for the timer, not for the clock of the microcontroller or the main cores. It was just the timer peripherals, which is still super duper useful. Like, that would be really interesting. A 5.4 gigahertz ARM core. I'm pretty sure at that point the manufacturing process, like the gate capacitances, are too high for you to go that fast. Like you'd be violating a lot of timing requirements. Um, okay, onboard LED. I guess that's it. Like you really can actually just use these things on their own. But anyways, besides the fact, let's get this going. Okay, so here's the microcontroller. Oh yeah, reset. I forgot about that. Reset button, maybe. Yeah, that a button is nice. Then I guess we could have a programming button. It would be cool if we had one of those like solder bridge gaps, and it's just like, oh, to program it, like put a screwdriver or like a piece of metal on it instead of a button. Just one less part. I learned everything from 8085. Pick 8 Arduinos, STMs, anything. What's that? 8085. Oh, that's cool. Oh, I've never heard about this. That's really cool. Six 8-bit registers. Oh, so you actually like built all this. Did you use like an FPGA or something? Once you like code it all up. Arduino's, STMs, anything. Yeah. InMOS. Ooh, damn, this thing is ancient. But I mean, ancient stuff is like the best for learning, right? That's like the complexity of those systems could be understood by one person. Whereas, wait, let me turn off my video stream. Okay. The complexity of those systems can be learned by, yeah, first MCU developed. I do remember that. I think the first job I ever had, we we were trying to like port over designs that used 8086, so like the predecessor or the successor to that one. And yeah, back then it was really cool. Like MCUs back then didn't even have their own internal memory, so like yeah, you had to route external like RAM lines and stuff, which was really cool. I was like, wow. Nowadays we don't even do that with computers. Like everything SoCs is just more and more tightly integrated. Um, Successor with better memory. Yeah. Damn, you know your stuff. This is really I'm learning a lot too. Okay, easiest thing is to get the grounds in, so let's get something done. Oh, I forgot, because this is a module, we have to be using terminals for how we connect everything. We can still connect everything to ground as like a net portal, but just so we can expose the ground to the end user here, I'm going to call this like ground terminal. Yeah, that's just what I do, and that just keeps it cleaner here where we can hook up everything. And then we're gonna have to add terminals to every pin, which is kind of annoying, because we want the user to be able to use this. And I think it's fair to connect all the grounds for them. Like, I mean, we could just break everything out, but then there's no point in making this sub module. There's only 3 grounds. Nice. VCC. So I'm pretty sure these are run on 3.3 volts, but let's actually pull up the data sheet for them. Okay, Mega AVR. CMOS 8-bit 8-bit microcontroller. RISC architecture. These things don't have that many peripherals, which is like right now you don't right in like the modern age when you have so many options, you're really looking at all those features. So it has 2 8-bit timers, separate prescaler compare modes, one 16-bit timer, RTC. Wow, nice. Oh, I wonder if there's another oscillator we have to put for the RTC with separate oscillator. I don't know if that's an internal oscillator. 6 PWM channels, 10-bit ADCs, temperature measurement, programmable serial USART, byte oriented, 2-wire Philips I2C compatible, on chip analog comparator, power on reset, programmable brownout detection. That's kind of cool. Brownout is where your voltage drops below a certain threshold, messes up, like you just have unpredictable behavior because everything was designed to work at a certain voltage. External internal interrupt sources. Oh, and it has sleep modes. That's really cool. Wow, I feel like these don't get. I mean, now I feel like they're exposed in Arduino, but I don't remember seeing these when I was playing with the Arduino. Correct me if I'm wrong. If people know what code there is to like expose these sleep modes. Sleep mode is good too. Yeah, so you can actually implement it in Arduino IDE, and like I wonder if you could do this ADC noise reduction. That is so cool. or what that mode even does. Um, pin descriptions. So we actually kind of dive a little bit deeper into the Atmega 328. I'm learning this uh, on the fly too, because we can see the inner workings a bit more. Port B is a 8-bit bidirectional I/O port. Depending on the clock fuse settings, PB6 can be used as the input to the inverting oscillator amplifier, which was like that Pierce oscillator we're talking about, I think. Qatar 00 ADC noise reduction, I would prefer to have RCR filter. I'm not super familiar with that. I'm assuming some sort of like selective frequency filter. That's really cool. I think the ST ADCs have that. You can change like the value of the capacitor on the ADC pin, the SAR ADCs. The internal calibrated RC oscillator is used as the chip clock source. Okay, port C is a 7-bit bidirectional I/O port. AREF. And I do want to name all the terminals, all the pins here, the same as like in Arduino. So from an Arduino user standpoint, if they're implementing this on their board, it'd be like more intuitive, like, oh, I just have something on D8 or something. And yeah, I'll just have that. They'll just be able to see all that. Okay, let's keep going. Data retention. Whoa, 1 ppm over 20 years. That's pretty good. 1 ppm is 1 part per million over 20 years. Or 100 years at 25 at room temp. In 100 years, 1 part per million data units will fail. I don't know if that's good or not, because it depends how much memory, how much data you have on it. I mean, obviously, the more data, the more is going to fail. Okay, we have our 8-bit data bus. ALU. Oh my god, I haven't seen a block diagram explaining this in so long. What does ALU stand for? Algorithmic logic unit or something? Arithmetic logic unit. And those can perform your instructions like add or like you take these two 8-bit values, you can do math on them, perform logic on them. Instruction decoders, program counter. Oh my god, I haven't seen this in so long. It's like microcontroller architecture class, program flash memory, instruction register, instruction decoder on the control lines, EEPROM. This is so cool. Yeah, another nice thing about these like super simple 8-bit microcontrollers is that the datasheet's only 653 pages. Oh, this reminds me of your engineering days. Yeah, I know, right? Like, you'll never find this in a ST microcontroller datasheet because it's so much more complicated, or it's just like you're never gonna get through it because it's 3,000 pages long. This is literally a third of it. So also, I just realized it's 653 pages, so I'm not gonna scroll through everything one by one. Let's just go to the application. Oh, cool. They have like, is this assembly? Damn. I feel like Arduinos are more fun to program, or like at AVR microcontrollers are more fun to program in assembly. That would be so cool. It's MP lab code, I guess. Oh, I don't know what that is. Actually, I want to search it up. Oh, yeah. That's the IDE that Microchip has? That's very cool. I feel like, yeah, usually the IDs that they provide kind of suck. Oh, look, low power crystal oscillator, but I mean, I've had good experiences with the ST1. Anyways, these ones are of an inverting amplifier, which can be configured as an on-chip oscillator. Either quartz, crystal, or ceramic resonator may be used. C1 and C2 should always be equal for both crystals and resonators. The most optimal value of the capacitors depends on the crystal resonator in use, the amount of stray capacitance, and the electromagnetic noise of the environment. Some initial guidelines for choosing these capacitors are here. Okay, we'll go there. Assembly code. Yeah, Rafa. Do you has anybody actually written stuff in assembly? It's like kind of good, but then kind of annoying. There's just so much more boilerplate, but at the same time, it's kind of intuitive. Like because logic is so straightforward, it just happens and more measurable. 60 line hello world print. Oh my god, printing stuff is like infinitely harder. um Welcome Rafa. Yeah, welcome Rafa. Hey JK Lamb. Um Thanks y'all for watching, sticking around. Okay, crystal oscillator connections. Oh, cool. So 8 to 16 megahertz, 2 to 22 picofarads. Oh yeah, tables right here. How's everyone's days going? Friday. 16K clock. Dude, there's so much info in this datasheet. It's actually pretty good. And it's just one datasheet. I bet you there's also a reference manual that is like very difficult to read. Or lots of stuff to read. Low frequency crystal oscillator. This is cool. So they give you your max ESR. This is really high. 75 kilo ohms. That's pretty funny. I don't even know what the ESR of, I think it's in the milliohms. ESR of, oh, I think you actually have to like, yeah, so the quoted values for ESR capacitors are between 0.01 and 0.1 ohms. Yeah, we're well within our 75 kilo ohm limit or maximum. So you can really use like the shittiest capacitors for this, but I mean, X7Rs are pretty cheap. Reading the datasheet or going through the datasheet is an art in itself. Whenever I get a new chip, I swap with datasheets and manuals for weeks. Oh, definitely. Honestly, like 90% of this kind of like system level, I guess like integration. I don't even know. It's like systems level integration is just reading through data sheets and stuff. There's so much. Sometimes there's like hidden information that they don't put on the first page. Like I was wondering if any of the GPTs can help us. Katarp00. Oh yeah, the GPTs are great. Here, let's ask this GPT. Copilot. Let's go with. I mean, we could just copy right from the schematic here, but let's like stress test this this model. But also I'm just noticing that I think they used a part that has the capacitors. Okay, anyways, at Copilot, what should we ask it? What I'm not 100% familiar with how the programming works on these things, so I know like we have serial wire debugger for other microcontrollers, which is amazing. You should just use that. But how would I program this microcontroller? Let's see what it says. Not gonna lie, the schematic's pretty hard to see. I'm sorry. Thanks for pointing that out. Is this better? Is it like the UI, or is it like the size? Is it the size of this IC when I like zoom all the way out? No, the Arduino. Oh, this. Yeah. Like when I'm zoomed out all the way here, it's just like not great. Thank you. I will zoom in a lot more if I'm pointing something out. Thanks, Katarp00. Unless it's like something actually visually like a technical issue. Also point that out, please. Thanks. But yes, let's look for this. Ooh, pretty. I wonder if they sell these. 4.16 megahertz. This is not the one I looked for. Is it? No, yeah, this is the 60 megahertz one. Oh, it's obsolete. Oh no. China's gotta have it. Old technology. Look no further. Yeah, 20,000. Let's go. Obsolete. That's so funny. I guess you can only order this design from LCSC then. It's so funny. I think like somebody else has tried. Oh, so these have 15 picofarad capacitors. They're already added into the part. That is so awesome. It just saves you more hassle. And you could connect this to ground. It's just a messy PDF. Oh yeah. Yeah, I definitely agree. It is so bad. Like no use of terminals. Come on. So hard to read anything. Let's get this connected up. And the crystal oscillator, let's see. Not that it really matters. Pin 10 goes to, yeah, there's no polarity on these. So let's get a net portal. So we're not going to expose this to the user because I feel like don't really need this. They also have test points. I think that's you can test the test points with like a test jig, but I highly doubt the Chinese Arduinos you get do any sort of electrical testing. Yeah, I wonder if we should add test points. It's good. I never add test points and I always regret it. So xtal 1. And here we have crystal 2. Wait, that's really weird because they used pins 9 and 10. Why do pins 9 and 10 not exist? 10 and 9. Is this labeled wrong? Wait, let's not this. Yeah, pin 9 and pin 10. I guess we gotta go to the datasheet. I mean, I trust the Arduino Rev 3 schematic because that's like, I love the terminals. Oh, yeah, Rafa, these terminals are, I have mixed feelings. Like they're really great because it makes it easy to connect to, but at the same time, you'll see like in layout, they can get annoying, but they have their quirks and you just have to get used to those. Let's go back to the pinout. Okay. Forgot what package we're on. PD5 and PD6, 9 and 10. Let's confirm what package we're using. So this is the 32 TQFP and the PDF. So you're using the Atmega 328 AU. Yep, and the PDF. Oh yeah, you're right. Let's double check. They're using the same one. 328 PPU. 328 PAU. Oh, I don't know if the AU changes. I'm not sure. It might be like packaging or like gold. I don't know. But this one, this datasheet covers all of them. Okay, so this is for the 328P A, and we have 32 TQFP. Yeah, do they have a different package? Let's just search it up. That's a good point. Let's actually get the actual difference between them. Okay. DigiKey. Oh, there you go. It's the package. The package is different. Yeah, that makes sense. Thanks. Good catch. Good catch. That makes sense. And if you look here, pins 9 and 10 are the crystal oscillator pins. And then for us, I thought the Rev 3 used one of these, but I am not up to date with my Arduino. I think we're using pins 8 and 7. Yeah, so we're in the clear. Good catch. That freaked me out. I was like, huh. But I mean, these are all the like little things that you get an eye for. I feel like I never would have noticed if I haven't made that mistake in the past. Thanks everyone in the comments who caught that for me, that different package, much faster than I caught that. Okay, the symbol is so big. And then let's add a note for anybody like looking in here. Let's have I'm just gonna move all these into their own section, like the terminals. Let's add a text note just to be like, this is the crystal oscillator. Whoa, why does it look so different? What is this? Note 1. This is the 16 megahertz crystal oscillator with internal 15 picofarad capacitors. You can choose to not populate this. Okay. So yeah, just for any other user, like if they want to use the internal clock, they can. Oh, and then enable this. Package is different. Okay. Wow, that was so easy because it has the internal caps. Like that's just one part down, 1 out of 3 or 4 things. So we have the oscillator, check. Could put like a line there if we're done. Decoupling caps, that's easy. As we could choose a package size for the user. 0805s are easy to place by hand. 0603s are like, maybe for an absolute beginner, maybe it's pushing it. No way are we putting a 402s, but I mean, y'all can vote. Do you think I should would you rather, as a beginner in electronics, solder an 0805 capacitor or an 0603? Because I guess like we would want them to make this out of a, like to be able to be manufactured with a soldering iron. The thing is, it might be hard to find. Oh, and then a 1 meg resistor. Oh, let's actually do that. resistor. Oh, and then let's link this. Learn more about it here. Ah. 0402 by hand is not too bad from a friend. JK Lamb, I don't know what you're what you're talking about. I am not him. Resistor through hole. Oh, you're right. Through hole resistors. Ugh. But I guess like the part is surface mount. Yeah, you can't even solder this on. Now that I think about it. I guess like oh okay. You know what? Because this is a surface mount package, let's just make this surface mount manufacturable, and then we can do a through hole version for people who only have. So instead of level 0, let's call it like surface mount SMD. So you would need a SMD manufacturing, need a hot plate and solder paste, or you can order it pre-manufactured. 021 with the tweezers. Yes, I had a friend who could run reliably solder 042s like all day, and then also he has like an 80% success rate with 0201s. Dude, when he like sprinkled out his resistors, they were like smaller than an eighth of a grain of rice. Like you could not even see them. Smaller than freaking ants. Yeah. I wonder if there's like a scale 0201 next to coin or something. What? No way. Those are not 0201s. Those look pretty big actually. It's just so funny. Yeah, let's go. Damn. Tombstone effect is the worst. Yeah. And you can't even see it. Ooh. Oh, this is so pretty. I love this picture. But yeah. Tombstone effect. Yeah, I think you can get that post manufacturing too. Just as like a tidbit of information, if your thermal gradient across your, or like if you design it so poorly that one terminal heats up, it can actually more than the other, it can actually unsolder itself, which has happened in history. Let's get these resistors later, and we'll have to remember to do that. So this is a 1 mega ohm resistor. Because this is manufacturable, this is SMD, I'm going to go with 0603. That's like, it's not unreasonable. We're not going for ultra dense design, but it's also easier to find. If we go 0603 for everything, like finding a 0805 10 nanofarad capacitor, I'm sure it exists with like a very high voltage rating, but it's going to be more esoteric. Okay. So we have, oh yeah, we're going to move on to the decoupling cap. So yeah, again, like I'm just going to put generic capacitors here to save some time. Let me get some water. I don't know what that sounds like on stream, so I'm sorry if it was disturbing. But we can turn this to like an ASMR water drinking stream if you guys like that. Let's go VCC. And there's the analog 3v3. Oh yeah, 3v3. That's all down here. Let's, I don't know, like 10 microfarads. I wonder what they use on the Rafa likes that. Rafa's a fan. I mean, we can use our common sense here, but let's just see what they're using. Whoa. Wait, this is a 5-volt microcontroller? I didn't know that. Wow, I totally didn't know that. Um, they use 100 nanofarads, and yeah, this is 5 volts. I didn't know that. I should have searched that up first. Yeah, the AMIC 328 is 5 volts rated. Oh, welcome, A13 Tech. Thank you. Yeah, thanks for the comment. I totally didn't know that. Technically, it can be run anything between 2.7 to 5. Yeah, I think so. If you're running at lower voltage, you cannot clock as high. Wow, I'm learning so much. Yeah, I'm pretty sure that somewhere in the datasheet, you're a champ for knowing that and reading through all this. But I mean, I feel like let's go 5 volts for the application people are using this in. Yeah. I mean, we have to think about the target user here. It's like, oh, I wonder if modern stuff is like 3.3 though, and they might need more level shifters. Okay. I think I don't know. Does anybody else, not me thinking you'll be using the CV? Is that the USB to serial? USB to serial. Oh shoot. Converter. Nope, it is not. It's another microcontroller. That is pretty cool. Ooh, this is really cool. RISC-V microcontroller. 48 megahertz main frequency. One wire serial debug. Yes. DMA, dude. This thing has DMA. A bunch of 10-bit ADCs, op-amp comparators. That's actually pretty sick. Huh. These are cheap, right? I made a board with the CH32. Oh, why is this the first time I've heard of this? I feel like I'm so behind. Um, can you get these on like? Oh, the chips are just 10 cents. Is this on LCSC? Because that's cheap. Now you can program it with Arduino. Wow, that is really cool. I just bought 100 and they're on the way. Oh my god, I'm so like out of touch with the microcontroller world. Yeah. Damn. That is pretty cheap for QFN to QFN package. That must be more expensive than their TSOP or whatever. Non LCSE. I'm a friend of the CTO. Oh my god, you guys are like important people. I'm a friend of the CTO in the company, and LCSE does not sell them because the margin would be too low. Yeah, I mean, we're selling them for like 10 cents a pop. Okay. Distributor. I kind of want to like learn more about this now. I mean, it kind of makes sense why it's so cheap. You don't have to pay. You don't have to fork over money to ARM. Another microcontroller that I didn't know came out, but can't come out was the ESP32C6. This thing is sick. It runs on like this is for IoT at least. Runs on like RISC-V as well, so don't have to, again, cheaper because of that. Holy shit, it's only $3. Wow. Okay. It has Wi-Fi 6. Like what? Why do you need that much? I mean, there's probably something else you need from Wi-Fi 6. There's Bluetooth LE. It has Thread and Zigbee. That's actually super impressive. I kind of like make an amplifier for that Zigbee radio. I actually don't know if you can. I don't know if you can do something like that, but that like Zigbee and Thread, that is just like for like what, $3? That's insane. Um, Qatar, you get them for $2. Yeah, yeah, and that was like distributed through Adafruit, so they're making a 95-cent margin on that. Wi-Fi 6, yeah, like what do you need Wi-Fi 6 on a microcontroller for? Like, what are you doing? Um, but I don't know. There's probably some application that is like, yes, it has Wi-Fi 6 now, and everyone's like super happy. Um, I am not part of that party. By the way, the at Mega 328 is officially declared EOL end of life. Yes. Um, I would not recommend using one of these things ever, but for educational purposes and like for beginners, it's really funny using like doing stuff in education. They use like super end of life stuff, and we're kind of coming up to the year where there's no more stock of these like super ancient matched like transistors. It's like, oh shoot, what are we gonna do? We can't buy any more BJTs for the students. Um, Probably future proof lower power. Qatar 00, I need that foil hat on my head. Yeah, make sure you don't get brain cancer from all the Wi-Fi 6s. The ceramic oscillator still needs a bias resistor. A13 tech. Yeah. Are you referring to this one, or is there something else I'm missing? I'll wait for that to. Yeah. Okay. We're chilling. Yeah. Let's get those decoupling caps on. Sorry, I like talk a lot. This is a pretty cool live stream. I think everyone's just into microcontrollers. Like I should make a poll of what got people into electronics in the first place, and I bet a lot of us are gonna go with are gonna say Arduino. Um, when I was a wee little boy, I wanted to buy an Arduino because it looks super cool, and then you start digging, and you learn a lot. Yeah. ESP32 is S tier. A13 tech. The NOT gate in the MCU is biased with the resistor to have VCC and then acts as an amplifier for the oscillator. Wow, A13 tech knows his shit, like or her shit or whatever. Um but here we had this pulled up. I briefly learned about it. You know way more about it than I do and understand it more in depth. I just know it exists. Thank you so much. That is cool. So it biases it to half VCC. That rings a bell. And then acts as an amplifier. Very cool. Not really use the ESP32 family much. I'm more of a power person. Hey, A13 Tech, you should stick around because I also am a power person, kind of. I just have more experience in power. The other project as a plug that I've been working on is this. So trying to build, I kind of like fleshed out the amplifier more. A13 tech, they, them, she, her. Okay, thank you. Yeah, everyone put your pronouns if you prefer. So at least experience in power. As a plug, because we can kind of just go off the rails here in the stream, and you guys are having a great time. My new, like, I want to build a high voltage power supply that is based on, so like, this isn't a very traditional. Actually, it kind of is. Like, this is pretty traditional. This is like high power systems do this topology, but I wanted to do like a 500 watt class D amplifier, a full bridge amplifier. I don't know exactly what all the advantages or disadvantages are. I just know there's something with like current back pumping current is like the terminology they use, but full bridge class D amplifier with like 7 megahertz GAN FETs. And that way we can use our microcontroller to generate, our sine wave. It'd be very interesting to see what kind of control algorithms we can use, and if we can even implement like zero voltage switching to make it like a soft switched power converter. Also, even cooler, I want to make this current fed, which I don't know if it's like that feasible. And transformer, Cockcroft volt and multiplier, and yeah, hopefully we get like 5 kV with like decent power output, maybe 500 watts, maybe more, depending on how good these Class D amplifiers are. Fancy, yeah. So that's like, stick around for that. I might do that in another stream as I flesh it out more, because um, this is still kind of new to me. I'm just kind of fleshing it out. Another thing is, I'm not a genius. GPT is. I've been asking hella questions to GPT, and GPT is like, or Copilot. Copilot is really cool and smart. Multiplying voltage by Cockcroft Walton multiplier. Oh, A13 tip. I had a bad accident with high voltage ER going through my heart rhythm off a week or two. Always take precautions. Oh, that's like really unfortunate. Sorry to hear that. If you want to share more about it, you can, but also if you don't, that's fine. That really sucks. Did you like touch it with both hands? It's all fine. Yeah, definitely take precautions. I used to work at a high voltage company, and I am so shocked. I probably shouldn't say this on stream, but like that nobody got shocked. Well, people did get shocked, but like nobody got hurt, which is really impressive. It's like, yeah, you got to be careful when you're playing with like 5 kV, 10 kV, anything over like 120 volts or something. To get into the hundreds, even DC, you got to be careful. Kayla, the safe precautions or guideline that you refer. A13 Tech, I don't know if you have an answer to that question, but for me, yeah, I wish there was good high voltage documentation. For me, my understanding, which might be wrong, but my understanding is if you have induced like a voltage potential across both your hands, the likelihood of that, like the current traveling through your heart, is pretty high. So if you always are like thinking about the situation, the ground path, depending on depending on how high the voltage is, the frequency of it, and the ground path, like what you're standing on, the floor itself at high enough frequencies can be the ground path. Thankfully, it was just across my hand. Okay, that yeah, that's really good. That would be really bad if it was like across both your hands. A13 Tech. Physics saves lives. Yes, physics does save lives. Thinking about the physics of everything. But Katarp00, like I hope somebody here knows if there's some guidelines, but the best I know is just to always think about that ground path. Think of your body as like a capacitor at high enough voltages, high enough frequencies. And when you turn on a power supply, there's like lots of high frequencies, because the transient of that like square wave. And yeah, with enough power, like these power supplies, when you're in the hundreds of watts, that's definitely enough to fry you. It'd be really cool if you measured your body's impedance with like a VNA, so you knew at every single frequency what your impedance was. But I don't know what that would entail. You would have to be like, some current would have to be flowing through your body. And Rafa is saying, I'm fine with 3.3 and 5. Yeah. Yes, those are much safer. It's much more chill. You just sit here and like plug everything in and it works. It flashes. It's really fun. In Germany, A13 Tech, in Germany, we have the typical VDE 5 safety rules. I did not know we have safety rules. This is really bad for me to be saying, but VDE 5 safety rules. This is so cool. Thanks so much for linking that. This is important. I mean, like everybody who works on safety, right? Good to check those every time. I recently moved, I think 1.8 volts. Oh, like FPGAs or like esoteric microcontrollers? Or are you just like most microcontrollers could just run off 1.8 and clock slower mobile stuff. Ooh, dude, y'all are working on some really cool stuff. I wanna hear more about that. If y'all want to collab later, hit me up. Katarp00. Here in India, there's very little documentation on safety. Yeah, I feel like a lot of places it's like that. Um, I work at a PCB company. Ooh, that is really cool. Yeah, PCBs, very fun. The rest is just my hobby. That's also super cool. I love that we all have this, like, we do things in our spare time. I feel like it's just can't get enough of it, like building stuff. Also, speaking of which, I should be building stuff. Let me get that PowerNet portal in. I feel like I've just been having a cool conversation with y'all. Plus 5 volts. I work as a hardware lead for a startup. Wow, that is fun. Oh, A13 Tech. Eisler. Oh, I've heard of you. Okay. I don't actually know Eisler PCB manufacturing, if like what that entails. So I kind of want to learn more about this. Also as like my understanding, it's PCB manufacturing, Germany, US, currently adding DRC files. I have Eisler too. Whoa, this is so cool. What a tight knit community. Oh, I heard Eisler too in Germany. Okay. That is awesome. Um, I want more options for board manufacturing and like high turnaround time. So let's see. Can we visit the website? Ooh, €12. That's really good. Because anything in America is like $2,000 for one board. Congratulations. Uh, yeah, I might make one of these boards here. I want to try it out. I want to see how fast it is. 2 to 6 layers. Oh, and there's assembly. Ooh. We have a budget pool as well. Budget pool. Oh, like for other people to kind of get free boards. Um, whoa. Yeah, you know what? After this project, I'm gonna go get some quotes here. I'm gonna manufacture some stuff. Um, very, very cool. Okay, so let's get that 5 volts in. I know I feel like having too much fun here, and learning a lot. 5 volts. Oh, and then we need space for the terminals. Just like visually, I think making schematics is just like visually challenging. No, so we have prices with 8 days lead time. Oh, okay. We somehow can compete with Chinese fabs. What is it like? What is the one day? Do you have 1 day lead times? That would be very cool. I wonder if the shipping's any faster too. But yeah, I just we have 2 day for 2 layer boards. Okay, that's not bad. I mean, China usually takes about 2 days as well. They're like they advertise 1 day, but in reality, they're like, hey, we found some really dumb problem on your board that is obviously like not a problem. Do you want us to fix it? And because of the time zone difference, they get a day back, um, which is really annoying. But that happens pretty often. Uh, 1 day lead time. I wait for 7 days for a PCB. Oh, I mean like they manufacture it in 1 day and then they ship it. It goes through all this like uh bureaucracy or sorry, logistics, not bureaucracy. Just logistics is hard. Um, I mean, I'm definitely gonna try it out, Eisler, and I'll take a look. What? one of the hardest things about making boards, also at scale, and I'm interested in the assembly, like maybe scaling that with Eisler. Chinese manufacturers, it's like somewhat depending on your experience. I've had like good experiences, but I've also had like difficult experiences getting things assembled. It's it's a jank process, and I think it takes a lot of communication because there's no real like standard for it. Um, Once you get into the nitty gritty. Um, yeah, sorry. Finish my sentence, Katarp 00. It's like, yeah, it does take about 7 days to get it in your hands. And oh, when A13 Tech, 8 days lead time, is that like to my door or is that manufacturing? Because if it actually gets to your door, I'm not sure what lead time means in this context. Um, that is very impressive. Manufacturing. Oh, okay, okay, got it. Uh, but yeah, it usually takes like a while. So we have a 10 microfarad, and that's 0603. Let's just get that here. That's time we guarantee. Yeah, that's true. Sometimes it comes faster. It's also good to actually guarantee it because I've had, Chinese manufacturers guarantee it, quote unquote. Sometimes it doesn't get here on time. I always wonder what to do in those situations. Like, do you get a refund? How does that work? Or let's do 100 because they wanted to do 100. 10 mic and 100. That is the time we guarantee. Yeah. Okay, so we have our decoupling caps. Honestly, this isn't that pretty. I wonder if there's some way to make this. Yeah, let's delete this and move this out. It's also let's shift this. So I just like to keep my schematics clean, and it's somewhat subjective, but just the less clutter, the better. Moving things out of the way. Ooh. Okay, got that. Maybe we could keep that down here. I always use JLC and the PCBers in my door in 11 days from Rafa. Yeah, 11 days. Yeah, that is pretty average. I just wish there was something you can get like a PCB one day, like I kind of want to get a mill. I want to be able to mill my own boards and then, scale them later. Just for prototyping, it takes way too long. Like imagine telling a software engineer it takes 8 days to compile your code. I mean, when you like deploy, it does take a while, and I think that's okay. But just for prototyping to iterate, rapid is better. Okay, A13 Tech. The times we can ship earlier, basically we squeeze the budget panels in between the rapid panels. Oh, when there's a free slot. That makes sense. Um, that's really nice. Yeah, I forget that also like it's the more users you have, the faster you get because I mean to a certain point, but yeah, we're all sharing the manufacturing process. My door is in Mexico. Oh, Rafa. Yeah, that makes sense. The shipping times can vary depending on where you live. Katarp 00, only one time I got things very bad was the PCB stack was not very consistent across different batches. Interesting. A13 Tech, I had my own etching machine as a host, such a mess. I fabbed down to 10 mils. That is really cool. I really tried to have a etching machine. I think where I went wrong was I couldn't apply the film correctly to the copper. Like I didn't clean it very well. I didn't have a proper laminator. So when I etched it, I was able to get really good details because I had a resin printer. It's like I don't know how fine it was, but I think I had 10 mil traces and that was fine. But then when I exposed it, it was like, or sorry, when I etched it, it was just a huge mess. It was not laminated on correctly. But that is really impressive. It is really messy. I am there are raw PCBs with pre-applied film. Yeah, I think I might try again with that. But at the same time, like you're saying, it is messy with all the chemicals everywhere. Also, there's not good ways to dispose of chemicals in America. Um, so I'm originally from Canada, and there was like a hazardous waste facility right next to my home, and like tons of recycling facilities. In America, I think it's like the culture to just throw everything into the garbage. I shouldn't get too into this, but yeah, I just kind of noticed that. I'm like, wow, everyone just throws everything into the garbage. Like we used to separate it out and like put it into this bin, take the batteries to the recycling depot. Um, yeah, and there's just not many resources here. Like I'm trying to get rid of like dangerous chemicals, but it's like, where do I go? There's not much information on this. But anyways, pulls out the iron machine. Yeah, I think I got an iron from Goodwill, but I didn't do it right. User incompetence. Um, okay, we're not actually building. Okay, so your next thing is we probably have to worry about the ADC reference a little. Just put a decoupling cap there. Get the UART terminal connected up. Which pins are those? It actually tells you here, I think. PD0 and PD1. And then on our package, yep, PC0, PD0. So those are pins 30 and 31. TX, pin 30 is RX, and pin 31 is TX. 30 and 31. PD0 and PD1. Sweet. This is super confusing. I think like the way they swap them around. At this point I add solder bridges just to make sure I don't mess this up. UART MCU. So we should be verbose about which TX it is and which RX it is. So on the microcontroller, TX is pin 31. And the RX is pin 30. And then we'll look at the peripheral we're planning to plug in. Yeah. You need to be swapped or no. UART need to be swapped or no. Yeah, so it will need to be swapped when we plug it into our 6-pin terminal. So let's do that right now so we get that out of the way. 6-pin, or like 01 by 06. I hope this one works. Okay. Here, let's scoot this out of the way. Just because we can. Yeah. Nice. Oh. It's a little close. And then let's get the pin out of those like cheap FTDI. Let's go to Amazon. FTDI. Or like USB to serial programmer. Like this thing. Like I feel like everyone's got one of these. Unless something else is more popular now. CH340. Yeah. Actually, so A13 Tech, I don't want to I want to leave as few components on the board as possible. Oh, you want the header? Yeah, no, you're good. The CH340 is an excellent option. Cheap, easy, but I do want to keep this minimal for the user. Oh yeah, and for any new viewers, I noticed it went up. The count went up. We're working on a microcontroller bare bones module that you can drag onto your PCB design. Like just for beginners getting into this, you built your Arduino project. You're like, oh, cool. Now let's make a board. Let's integrate it so it's not like flopping around everywhere. And I want to make this as simple to manufacture as possible. So we're going to keep the part count minimal, or leave a lot of these like optional to assemble. And then A13 Tech, there is now the CH343, which is faster and now supports 1.8 to 5. Wow, dude, people are updating their stuff. This is sick. Yo, and they have a board you could get here. I'm gonna need more water. So I use the CH340E. Yeah, I wonder if you can get these. Let's just search it on Amazon. The new one that A13 Tech is talking about. 343. Ooh, I like that layout. It's actually pretty clean. The ground vias on the outside. That's just really nice. Nice touch. It's just like, I just love it when people put effort in like that. You know, like it's like not absolutely necessary, but it's better in some way, and it's really pretty. Again, I'm friends with the CTO. Sometimes I have to see stuff from WCH. Is that the manufacturer of these? Y'all are super cool. Manufacturing. Or I'm learning so much. I'm learning all about. Oh, this is so cool. Wow. Bluetooth LE. PCIe? Wait, hold up. Oh shoot, they have so much stuff. Wait. PCIe. PCIe convert to quad UARTs and printer. PCIe bus convert to dual UARTs and printer. UARTs. Controllers. PCIe universal chip supports IO mapping. Extended ROM, flash ROM, interface chip, extend ROM protocol. Okay. Not what I'm into, but that is so cool. They make all this stuff. YADC Qatar. Oh wait. So somebody. Oh yeah. Some Rafa has actually made a USB to serial adapter, which is super cool. Let me pull that up. That is sick. Ooh, it's pretty small. I like it. So Rafa's got one of these built. And then YADC is ADC good. CHD is just trust my design. I think that two capacitors. YADC, it's a USB adapter. Oh, the 10-cent chip. Yeah, I know it gets really confusing with the CH. Just tested the basics so far, but the 10 bits is pretty good for that price. Yeah, again, also it depends on what you care about. If you care about like the linearity of your ADC and like the effective number of bits. But yeah, 10 bits is, I mean, you're paying 10 cents. Like if you care about linearity, I would definitely look into that. But if not, like it's just some sensor stuff, you're probably fine. But I have the PCU in my hands and it works great. Send that TX and RX signals. Yeah, that is awesome. If the pinout, I'm going to match a pinout for this so that people can order it on Amazon. But if it happens to match the pinout of your design, Rafa, that would also be super cool. You could just plug your board right into this like Arduino pinout. And you can always like swap the pins with, the standard headers. I used to work at a company that like my job was to crimp wires for these connectors. And like, I don't know if we have automated machines now. Like we had machines where you like shove the wire in, it strips it and then crimps it for you. But there's still like, you still have to shove it in. So I wonder if those like headers, those like 2.54 headers, wires, I don't even know what they're called, like ribbon wires or whatever, like these things. I wonder if these are manufactured automatically or if someone still needs to shove it in by hand, because that kind of sucks. Oh, Katarp00, do you sell this design? Oh yeah, DuPont cable. Yeah, I wonder if those DuPont cables are like, I know the ones with like the 40 pins, the connector just like pierces the insulation, which is super nice. That's much more automated, but like the hobbyist ones, if those are still made by hand. Um, yeah, Rafa, are you selling that design? That could be a good source of side income. It'd be kind of fun, you know. Um, okay, what were we doing? Oh, we were connecting up this based on the pinouts. Okay. You know what? We have 30 minutes left. I do want to finish this. If we could actually finish this in 30 minutes, do a quick layout. I mean, there's nothing to lay out. There's like 5 components. This is mostly schematic work and documentation. Pretty different from my last video, my last stream where we built the Raspberry Pi. That was a lot cooler. There was another company making these that was like really, really cool. You know, I'm gonna look around a bit more because I can't remember what it was called, but I purchased it before and it looked pretty professional. Hmm. Maybe you were. It was on Amazon too. It was like, oh, these things, null sum. They're more expensive, but look at that. It's just so small. I just love it. It's so much more clean than the other ones. Just your 4 pins, 5 volts. USB-C as well. You know, I don't. It is more expensive, so it's less accessible. Although I would recommend buying that just because it's just so much cleaner. But yeah, let's get these. Let's get these going. I don't really know what people would be buying here. Again, I'll just go with this. Like, I wish I had the pin out here. We could just do a 3-pin, a 4-pin connector, and like have people like if you were to do this, you would just put your programming wires in. Yeah, you know, let's make it. Let's support this clean USB-C with compliance, right? I mean, if it is compliant, like super cool. It's just so clean and so good. Where was that product? USB to UART. Oh, it's called nullsum, so I could Google it. Oop. What? Oh, here. Why is this not the first thing that? Oh, it changed to Nelson. Come on. Okay, so ground, UART, TX, transmit. I mean, it's pretty straightforward. So let's get rid of this. Keep it smaller. 01 by 04. And we have to think about like crossing the signals and everything. Let's see. So if we go with this as ground, then RX will be down here. That makes sense because, yeah, the signals get crossed. So the TX, the pin adjacent to the ground is the RX, which is receiving it from this. And then TX is going to send it here. I also like how they used arrows. That's just so much more intuitive than what's it called? Like calling it, labeling it TX. Yeah, put those arrows in your design, Katarb00. Let's totally do that. That would make it so much more intuitive. I'm totally on board. Okay, we got our programming header, and let's recommend in a note. Leave a note for the new players. If y'all, everyone in the chat, if you all like what I'm doing here, let me know. But if you want to go more technical, if you want to see that like high voltage power supply design in the next one, let me know. Or we could geek out about microcontrollers. We can do another one of these with like an ESP or something, and I'll talk less, or I'll figure out how to do more work while talking. I'm sorry. Okay, this is the your header. The recommended programmer can be found here. And I heard, oh, I wish we could get like the link is so long. There used to be like a share button. Share. Why is this not a button? I can't share this link. Yeah, this is just gonna be way too big. Oh, this is really cool how you can actually like click on the link. And then let's add this. Oops. And let's say, like, if you're a beginner, you're getting this. If you use another programmer, or just say, oh yeah, if you're using another programmer, feel free to use 4mm or like DuPont wires to match the pinout of the design. Only TX, RX, and ground need to be connected for programming. Okay. All right. We got that going. And then the reset. Let's just tie a button to the reset. Also, I can't remember if you need to like press some boot button on the Arduino. Let's double check. Oh, and they exposed the analog reference. Oh, yeah. Yeah, I guess we could do that. So all this. They also have it in ferrite bead. I wonder if we should put that 10 microhenry ferrite bead. I think it's fine. I've never had a problem. Actually, in most of my designs, I do have ferrite beads, but reset enable. It's tied high. Oh, and then that's connected to the reset on the UART. I wonder if we should break that out too. Nah. Yes. is broken out in the TTR pin. Yeah. Oh, but then I have to get a 5-pin header. Okay. Yeah, I'll do it. I'll do it. Oh, they have been making them. That is so cool. Oops. Let's just offset that by 1. So yeah, this would be a custom. You would have to wire this up kind of like with that DuPont wire. Bruh. Come on. You know what? I'm just gonna delete all these. Ugh. Yeah, honestly, the UI needs a bit of polish, but it's coming. It's coming. Okay. The unfortunately, the recommended controller I had doesn't have the reset pin, but um we'll add this here for anybody who's gonna wire it. I might go in and make it like another revision where they don't have to do this. Reset. CU reset. Yeah, it's nice. So you don't have to push the button yourself. And then there is, in their schematic, it looks like, yeah, reset goes into their programming. No, what is this? This is just power. There's a reset pin. Oh, and here's the button. This is so hard to read. Why are the grounds upside down? Come on. Okay. USB boot enable. I already lost what I was looking at. Okay. I don't think this diode is necessary for us. Let's just tie a... Let's just put that there. Put a pull-up resistor. I don't know, like 10K. I think they use the 10K as well. But yeah, A13 Tech, thanks for letting us telling me to put that there, because it would have been lazy for me not to, but it's definitely helpful. It makes programming a lot easier. Okay. And then I guess the rest of the signals will just break out for the user. Oh yeah, and then the button. What's the most commonly purchased like tactile switch? I'm pretty sure there's a whole category for this. Oh, those are huge. I really like these ones. They're just like so nice to press. However, I do want to make sure that it's like a very common switch that you can get. There's like this through hole switch, like yeah, this thing that just comes with all these like starter kits. However, these are so nice. Yeah, they could buy it. They could buy a switch, like, and they're not that hard to solder. Can't really mess this one up. I haven't found that like through hole tactile switch. Maybe I'm like only looking at SMD ones, but this one is way too big. This one's also big, but whatever. It's nice. I think we actually have that in the library. Yeah, let's go. The footprint, I mean, the symbol is just so ugly. I'm sorry about that. So we want this to just tie it to ground. Oof. I think in their design they had like a capacitor across the reset here, which would go to the controller. So the controller is tied low, and then for the DTR pin. The one underneath you showed me looked pretty generic. A13 tech. I'm not sure when that came in, but I think if you're talking about the switches, um, you should look pretty generic. Yeah, like one of those. Yeah, that one's pretty generic too. These are all like, yeah, you see these everywhere. Ooh, that looks so cool. I'm actually I want to implement this in some design. That is so cool. Oh, the package on this just looks so nice. It's like membrane switch or something. Brick noggin. Okay. So we have our MC reset that goes to ground. Pretty basic. This is pretty much it, right? Like you have your oscillator. It's really important. You have some decoupling caps, not mandatory, but really important. You have some way to program it, which here is UART, which is pretty nice. And I'm assuming it just enters in. You could just start programming it once it gets reset. I always found that kind of weird, programming it via UART, but it doesn't look like there's anything else. This ICSP is just connected to the SPI bus. These are power supplies that we're not going to implement here. Here's like circuitry so that you can plug in VN and the USB. That's interesting. So a comparator, I'm assuming that's a comparator, drives the gate. Kind of using this transmission gate style. Okay. And this is all the stuff that we don't have to worry about. So we're like pretty much done. Yeah. With 20 minutes left, let's see if we could lay this out. It's not that complicated. However, we do need to add terminals to every pin, which is super annoying. I might go do that later because, again, it's super annoying. Not very entertaining to watch. Yeah, I mean, we're kind of ending the stream. Like, the stream is coming to an end, so feel free to chat, ask any questions, like any tips, any tidbits of knowledge you've experienced recently. Yeah, I'm just going to finish this layout. Pretty chill. So here's VCC. Also, I do layout without the top overlay because that's really annoying. This looks like it'll work. VCC ground. We could add a third footprint if you really wanted to go ham, but for most use cases, you'll have a pretty clean supply. The crystal, it's a good orientation. Oh, you know what? Just to be edgy, let's do, I wonder if you could do math here. No. I can't do math. 315 degrees. Yeah. I like that. Does anybody else do 45-degree components, or is that just cursed? I personally love it. It's such a nice touch. Cursed. JK Lamb not on board. I I just love it. I can't get enough of it. Oh, let's go like 135. Yeah. Oh no, that's too much. Oh, I love how it the hotkey. So right now I'm pressing hotkeys to switch the to like rotate it. It actually just adds 90 degrees or subtracts 90 degrees to the rotation parameter, which is super nice. Um, Cursed, and like we're not going for ultra density, so we could keep things a bit more separated. Um, and let's just wiggle this. It is kind of cursed. But 45 degrees with squiggly traces equals cursed. I made a board. I wonder if I could actually get it on camera, but it's better if I just show the design. I made a board with totally only curved traces. It was so bad. It was like that was cursed. Um, Maybe I'll pull it up as I'm doing this layout. Oh my god. Oh, the lag is real. My computer can't handle streaming and designing at the same time. Oh. We're connecting to PD0 and PD1, so these go here. Oh, okay. It's smoother. Um, what is this? R2. Oh, that's just the pull down resistor. Oh, on the reset pin. Yeah. I mean, that can go anywhere. This looks like a safe spot. Oh my god. Wow, the performance is really taking a hit right now. Oh, I do want to keep this far away so they can actually access, the user can actually access these pins, if they so need to. Sorry for the lack of density, but I mean, this is so bare bones. Like, look at that. Let's go into 3D view. That is really gonna cook my computer. I also have 3 Chrome instances open. Oh, maybe it would help to close these instances, or like freeze them somehow. Here, yeah, there you go. Look at that. That might be hard to push if your programming pins are there. It'd be kind of annoying. That's it. It's just 2 capacitors, your crystal oscillator, and your programming port. It took 2 hours. I'm sorry, but I had fun. I had fun talking to y'all, and I do want to leave as many notes as possible for beginners. Although it does look kind of daunting, you know. You kind of come in here, it's like, yo, what the hell is going on? But let's see if I can find that board. In my defense, I've never used squiggly traces before, so can everyone see the? Let me just double check. Yeah, look at this. I wonder if I have any 45-degree parts on this, just to really, really rub it in. No, everything is aligned. This was my one chance. I could have done it, But yeah, I think A13 Tech earlier was talking about how you have to dig through data sheets. Katurbo. Yeah. Thank you. But you have to dig through data sheets. This was for a Google Coral SOM. Um, like the system on module would plug into these mezzanine connectors, and what's it called? Uh, this crystal oscillator um, was required on the HDMI pins so that the thing could boot, and they put that in like page 60 on the data sheet. And if I didn't just read it for fun and just like browse through the whole thing, I never would have caught that, and it just wouldn't have booted. Like that should be on page 1 or like some very important stonks. Yeah, the memes are so good. Actually, I took this photo, this graph I got from uh this actual board. It's designed as a EEG sensor, so it attaches to your body via like this gel pad, and it senses muscle electrograph like inputs. And this is like a spike from me closing my muscle. But then I pretended like it's the economy, you know, Dogecoin. uh, and this is even more cursed. Like I think I was just like out of time or something, but like what is going on here? Like just connecting all these ground vias to this is, I thought, do I not have a ground plane on the top? Why did I do this? It might have been because like there's a antenna here. No, this is the antenna keep out. Did I just not add like a ground plane on the top? Yeah, look at this. This is just cursed. I'm not proud of this in any way. But it's actually pretty funny. It's interesting to look at. Planes. I know. I don't know what happened. I think I added all these power planes and then like for everything else, but then yeah, I honestly don't remember why I didn't add a top power plane. Maybe like the performance was just getting bad, but I don't think so. Um Rafa. Yeah, you can look at the glory of this awful board. I think there's more memes on the back. The 3D view is not intuitive. Great Scott, that's it. I feel like I had better opportunities here. What's it called? I so many ground traces. I know. Okay, this is getting embarrassing. I'm gonna close this off. But yeah, if y'all want to like build something like that, you know, some deeper embedded project, that took me quite a while to build. It's also like EZDA was not very well documented. Just trying to figure out how to do things I wanted to do. But yeah, I mean, I could finish routing this while like time is coming. But if everyone has any feedback, any like desires for what we should do. Oh, look at that. When you do 45 degrees, it just plugs in so nicely, except for this one. Okay. I don't know if I'm ashamed or proud of this. These things draw such low power, but doesn't hurt. Oh, everything here doubles as a ground plane, which is, or sorry, as a test point, which is awesome. Except for when I have to connect every single terminal. That's gonna be really annoying. Yeah, let's do it. Terminals. God, having to know. Oh, I guess let's just take what the symbol says. ADC6. let's keep this simple. So I want to match the pinouts. ADC0, D14. We could start with all the like D1 through. How is RX and TX open? Is there another? Let's go into their schematic. Yeah. Oh, I didn't know RX and TX were also just like you can have it. Interesting. I guess we'll add terminals for that too. Sorry, I'm just looking at the pinouts right here. The ADC stuff, I'm not. Oh, it's just A0 through A5. Yeah, we have ADC6, ADC7. Honestly, not sure what those correspond to. D13. Oh, it's all. Hey, I hope this helps. Nope. There's no pin labels. Come on. TP0. This is super unhelpful. Oh, here. Does this just have less pins? PD0, PD7. So here we have D0 through D7, then B0 to B5. B0, I think it just goes to D. Wait. Oh, no. B0. Why is B0 to B5? PB0 to PB5 is connected to... Oh, this is the analog ADC 0 through 5. This is PB0 to PB5. Got it. Okay, and then the rest we'll name our own bonus pins. Let's go P. It starts PD0. So that starts here. Oh, the UART port is on a different... Why is it PB6? Wow, that's so annoying. The pinouts are so different. I wonder if that'll cause problems. Here, the UART programming port is... if I remember off the top of my head, PD0. Yeah, RX. PD0 and PD1 for RX and TX. But here we have UART on PD0 and PD1. Oh, what the Oh, I'm looking at the crystal oscillators. I'm so stupid. I think you're using the same MCU as Arduino Mini, I guess. Oh, Katarp 00. I am so out of touch with... Yeah. Arduino or Micro. Damn, I should have taken this schematic. Fuck. At the 3 minutes before we end, I just found the right schematics. That's so funny. Oh my god, this is so much cleaner. Who designed the first one? This is so cursed. They didn't sign it. This is so cursed. And then like this is just... No, you're good, Qatar, but I meant like my bad. I was like, oh, I totally didn't know this existed. I should have did my research. But I think that's kind of I don't know if y'all like that I didn't do my research and it's more spontaneous. I just kind of do whatever. But I don't know. I mean, a little bit of research is good. Oh, they use a completely different part and they actually put their own capacitors on because the other one got depreciated. Okay. Okay, anyways. A completely different MCU, yeah. Oh yeah, it's the 32U4. It's not the 328. What's the schematic they use for those Chinese Arduinos? Because like when you Arduino Uno, let's just let's just look for an Arduino Uno. The Elegoo ones, like on Amazon. Like these are the legit ones. Ooh, this one comes with the dip package. They just copied it like this, 328p. Like, look at that. Ooh, the hatch. Also Arduino Nano. Oh yeah, sorry. I thought oh, okay. This is probably the one. Schematic. This is probably it, huh? Yeah, 328p. Thank you. Oh, and it does use the same part. Okay. Yeah, so we're not that far off. This is literally what we did. Okay, 4.7 microfarad, 0.1 microfarad. The only difference is I went for a 10 microfarad, which is better. Oh, and then the onboard LED on PB5. Okay, this is a way better reference schematic. It just gets better and better. Like, this is so clean. USB, FT232RL, like identical. Okay, you know what? I'm gonna go copy this. This is so much cleaner. Screw the other one. This Elegoo are good. Yeah, the Elegoos are. Let's pull that up. I've used them a few times, long time ago. I can still remember when I use these. Used to make me smile. You have level 2 done. Yeah. Yeah, that's true. I have one. Yeah, they're so cheap. $16. Oh, the goal with this is like I want to compete like price wise with the Arduinos. Like, you could get all these parts for $1 and then maybe like $3. And then the PCBs are like $20 with shipping included. Or if you wait, like if you're not super into this, you can wait. And you can get it down to pretty much the same cost as Arduino, like $20. You could get this, all the parts and PCBs, and then solder it by hand. Yeah, hopefully like people actually go and build these. I really want I want people to get into electronics, get started. We did go over time. Time flies so fast. 5 minutes went by so fast. I don't think this is stream worthy, so I'm just gonna go and rename all these pins on my own time, leave more documentation around so it's less daunting. And yeah, hopefully this helps the community in some way. People can be making more PCBs. Yeah. Thank you everyone for joining. I'll leave a new project link in the chat if anyone wants access to it. But yeah, peace. Have a good rest of your day. Thanks everyone. And let me figure out how to stop streaming.